Okay, Algebra 1s, let's look at starting our solutions to systems of equations using graphing. So what does it mean for something to be a solution to an equation? That means that the xy ordered pair makes the equation true. Okay, a system of equations is when you have two or more equations on the same coordinate plane. That means you're considering two at a time. So it becomes important for us to know, how do I know if something is a solution? How do I know if it works? And we want to make sure that we consider, if it works, then this xy ordered pair is going to make true sentences when I plug it in. So if I have 2 times x plus y is equal to 3, that means if I plug in x and y, I should get a true number sentence. 2 times 1 is 2, plus 1 is equal to 3, 3 is equal to 3, therefore, yep, it works for this one. In order for it to be a solution to the entire system, though, they have to both be true. So I need to take the time to figure out my second one. So I have my x value minus 2 times my y value is equal to negative 1. I'll plug in 1 and 1 from my xy ordered pair. So when I have 1 minus 2, does that equal to negative 1? Yes. Negative 1 is equal to negative 1. Therefore, yes, 1, 1 is a solution to the system. Alright, let's check out this next one. I'm testing to see if this xy, 6, negative 13, works in both of these. So I'm going to substitute my x in, I'm going to substitute my y in, and I'm going to see if that equals negative 3. You can totally use your calculator for this to help you. All you need to do is type in this number sentence exactly as it appears. 5 times 6 minus 3 times negative 13. And is 69 equal to negative 3? No. Therefore, no, it is not a solution. It's not worth me checking the second equation because it didn't work in the first. It has to work in both. And I can cut my losses and move on. Alright, when I'm solving a system by graphing, before I can solve for graphing, I have to remember a couple things. I want to make sure I put my equation into slope-intercept form. I can add and subtract the x's and then divide by that coefficient. This is our coefficient. And then, of course, simplify. Solutions of equations are represented by an ordered pair for whatever xy point is where they crisscross. Think, if you want to look at two graphs and see where their solution is, you're looking at their intersection, where they crisscross. Alright, let's take a look at these two equations here. For equation number 1, I'm going to add x to each side, and that's going to give me y is equal to x minus 2. I'm going to come down here to negative 2 as my y-intercept. I have a slope of 1 that's understood. Rise, run, rise, run, rise, run. So I can go ahead and connect those dots and have this be my graph of my first equation. My second equation, if I add x to each side, I'm going to have negative y is equal to x minus 4. I'm going to multiply everything by a negative 1 to solve for y. Y is equal to negative x plus 4. Watch that sign as you share it out. Which means I'm going to go up to positive 4. 1, 2, 3, 4. And I have a slope of negative 1. So fall 1, run 1, fall 1, run 1, fall 1, run 1, fall 1, run 1. And here I have the 1xy ordered pair, or 1xy ordered pair, the coordinate pair where these two lines crisscross. Here it is. So over 1, 2, 3, and up 1 is going to be the solution. All right. Let's look at the next page. So when I have solving each system by graphing, what I need to do is make sure they're in y is equal to form. So this is lucky. That's already in. So because it's in slope-intercept form, here's my slope, there's my intercept. The graphing it becomes easy. So when I graph, and I'll zoom out a little bit, so that you can see the graph and the equation at the same time. Negative 4, 1, 2, 3, 4 is my intercept, and my slope is positive 2. Rise 2, run 1, rise 2, run 1, rise 2, run 1, puts me where I can connect my dots. And there's my first equation. My second equation has a slope of negative 1/2 and an intercept of 1. So I go to positive 1, and a negative 1/2 slope means fall 1, run 2. Fall 1, run 2. Fall 1, run 2. So then I can connect my dots. And I can see clearly that these two lines intersect right here at over 2 and up 0. So notice on the directions they said check your solution algebraically. What that means is once I find an answer, substitute it back into the equation and see if it works. So for this equation, I'm going to say 0 for my y is equal to 2 times 2 minus 4. Is 0 equal to 4 minus 4? Yes, it is. Therefore, I know it works. Down here, when I check, is 0 equal to negative 1/2 times my input of x is 2. Plus 1 is 0 equal to, this is negative 2 over 2 plus 1. Is 0 equal to negative 1 plus 1? Yes, it is. So therefore, yes, it is a solution. Here's the good news. You can do this with every single problem, and therefore you can always know whether or not you got it right. And if you got it wrong, go back and fix it for sure. All right, I need to solve for y, so I'm going to add 3x to each side. And I'm going to get y is equal to 3x plus 6. So if I start off at 6, 1, 2, 3, 4, 5, 6, my slope is 3x. Now I can't go up on my graph, so I'll go down 1, 2, 3 and over 1, down negative 1, 2, 3 and negative 1, down negative 1, 2, 3, and negative 1. That double negative movement is going to give me my positive steep slope of 3. All right, so when I look at my next equation, I'm going to add x to each side. So I know that my y is equal to positive x minus 2. When I come to my graph, I'm going to graph the intercept of negative 2. And I have positive x, rise 1, run 1, rise 1, run 1. But here's the problem. I'm heading away from a possible intersection. So I think I'll go backwards. There we go. And see if something else works. So here I have my graph. And it looks like these two lines cross right here. So that looks like over negative 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. So we can test to see if I did a good job on that. So I'll go ahead and I'll say, is negative 6 equal to negative 4 minus 2? Yes, that is true. I can test this one. Is negative 6 equal to 3 times negative 4 plus 6? Negative 6 equal to negative 12 plus 6? Negative 6 equal to negative 6? Yes. Therefore, I know I did a good job. All right. So check out these next two. These are the ones that are so easy, they're hard. Remember, anytime I have just an x in the equation, that's a vertical line with an undefined slope, and just an x in the equation, that's my vux. That means that every single equation, every single ordered pair starts with a 6. Who cares what's coming? Because my rule here is go over 1, 2, 3, 4, 5, 6. No matter what, I always have to go over 6. If I have a positive y or a negative y, it doesn't matter. I have to go over 6. All right. My next one is, of course, ahoy. So here I have a horizontal line with a slope of 0 and just a y in the equation. That means that no matter what I move left or right, I'm only allowed to go down 3 because my y's are always equal to negative 3. 1, 2, 3. That means no matter how far over I go, left or right, I could only ever go down 3. So when it comes time for finding this solution, it's, like I said, so easy it's hard. If x is only allowed to be 6 and y is only allowed to be negative 3, guess what? That must be my solution. All right, let's go. Let's keep working. Here I have two systems of equations that I need to graph. Now, unfortunately, these are both in standard form. X's and Y's are on the same side. But look, all of these are friendly numbers. So it's easiest if I have friendly numbers to use an intercept table. If x is equal to 0, I can cover that up and see that my y is equal to positive 6. If y is equal to 0, I can cover that up and see that my x is equal to negative 10. If I do my intercept table for this graph here, or for my second equation, if I cover up x, because that is equal to 0, I get y is equal to 4. If I cover up y, I get x is equal to negative 20. So guess what? That's going to be a little bit of a pickled to graph because I don't have negative 20 spaces to go. So I might have to go ahead and put these two equations in to slope-intercept form. So when I go to work with this equation here, I'm going to subtract 3x from each side. And then I'm going to divide by 5. That's negative. So my y is equal to positive 3/5 x plus 6. All right. 1, 2, 3, 4, 5, 6. I can't count up 3 over 5, so I have to go down 3 and over negative 5. All right, sorry about that. That was a phone call in the middle of the video. You have to let me know if you heard that ringing or not. All right, so I can graph this time at positive 6, and I can't go up, so I have to come down. Down 1, 2, 3, back 1, 2, 3, 4, 5. Notice my graph is still positive when I go ahead and I connect these dots. So when I go to do my other graph, solving for y, that gives me subtracting x from each side is going to give me negative 5y is equal to minus x minus 20. Divide by negative 5, divide by negative 5, divide by negative 5. My y is equal to 1/5 x. Think about that. Negative divided by negative is a positive. And remember, this has a coefficient of 1. So I can just write this slope as 1/5 plus 4. So I come up to 1, 2, 3, 4. And I'm going to go ahead and count, rise 1, run 1, 2, 3, 4, 5. And remember, I'm looking for their intersection, so I might go down 1, back 1, 2, 3, 4, 5. Aha, there's where my intersection is. So I count my slope towards where the other line is, because that's where I'm finding my intersection. Okay, now we have some special cases. So I'm going to stop the video here and check out these, and then on the next video will be the special cases.